Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Spot the Vuln solution will be on tomorrow's episode, and yeah, let's jump straight into our topics here.
Before we jump into the topics, I will also say thank you to Pux. I probably said that wrong, or Pux7, for the Prime sub.
Yeah, thank you. Yeah, that was during our pre-stream. I almost forgot about that. Thanks for bringing that up, Z. But yeah, so we'll get into our first topic, which is a Pre-Auth RCE in GoCD, which was discovered by Sonar Source. GoCD being a open source Java-based continuous deployment solution. So as you can guess, there can be some interesting issues there. The post goes into a lot of background detail on GoCD and the internal architecture. Mainly what's important from that is the concept of like a pipeline or a collection of tasks, as well as an agent or worker that checks for work and runs any commands that are needed.
I'm going to interrupt you really quickly and also say thank you, Imperial G, for the sub. Unfortunately, I had some tech issues and alerts are not going to be working this stream.
So disappointed.
Yeah,
No.
I just couldn't get him back up before the stream, but yeah, thank you for that sub.
Yeah, I mean it's tough when everything has to be set up again. There's so much to do with the stream, so it's all good. But yeah, sorry for the subs and whatnot for that. But yeah, so they go into a lot of background detail there. Those agents that I mentioned are authenticated to the GoCD server with an access token for doing sensitive commands. Um, Further, GoCD server supports plugins and allows requests to pass through add-ons. Previously, before a commit in 2018, sensitive endpoints were auth checked above the add-on level, so the security was kind of centralized to the core. But in 2018, a commit was made to shift that responsibility onto the add-on authors. So now the add-on authors are responsible for ensuring the user is authenticated on any exposed endpoints.
So,
So there
in
could be some popular
fairness,
plugins that just didn't account for that added responsibility. Go ahead,
well,
Z.
in fairness, all the add-ons were expected to do their own authentication before. What ended up changing specifically was any add-on that used /admin and /API. Those had some additional checks on them here. Yeah, you'll see the add-on /API in the patch. Had a couple more beyond just the assume anonymous user. Um, Although, yeah, it looks like it had like the OAuth authentication filter in there. So it does help. Like all the add-ons now kind of need to be aware, and that is where this issue came from. But it wasn't a complete change. Like it seems like that was probably their policy that they were expected to, and then they just kind of assumed that these endpoints needed a little bit of extra protection, which maybe need to be broken for some plugins.
Yeah, so the plugin they focus in on here in this blog post is the business continuity add-on, which contained three info disclosures, one kind of accidentally, seemingly, through a directory traversal, and the other two were intended but were supposed to be authenticated. So the first one they detail there is the plugin endpoint would take a user input plugin name and use that to construct a path for a file to serve over HTTP. That was vulnerable to directory traversal, which allowed arbitrary file read. Pretty trivial bug there. The other two were for the config file and the AES key for encrypting things like access tokens. So by combining those three sources of information, you can leak the configuration file, which contains encrypted environment variables, use the AES key that you can leak to decrypt those environment variables, and also get any other credentials you might want through the arbitrary file read, such as like Git credentials and stuff. Um, this is kind of
Well,
funny the way that these attacks work.
I'm not sure how, if it had Git access, how those credentials would actually be stored. If that would be stored on a file and thus accessible like this, or if that might be stored on another database off of this system. I'm not entirely sure on that, so I won't say that it necessarily had the Git token access or any Git credentials. It's possible for sure. I just don't know enough about how the whole application was structured. That said, I should also mention this plugin. is so it's a first party plugin built by the same people who are making like the main GoCD, and it's meant for, it's not an automated failover, but like if the primary server fails, this is running to kind of so everything kind of keeps working. So it needs access to like all of the application configuration and all of that. As you're seeing here, where you're able to pull out the apps config, like that's part of what it needs access to for this plugin. So very privileged plugin.
So I found this attack a little bit funny because of the ability to leak both the config file and the AES key for encrypting things like the access tokens. Um, this is kind of a case where like the crypto is just kind of useless. Like, yeah, you're using the crypto, but then you're just exposing the key. Seems a little bit strange. I'm just trying to figure out in my head like what the idea is here of if you're like if you're going to encrypt some data that's in the config file, you're thinking that okay, some people might be able to get the config file, but you don't want them to read this sensitive data. But then if you're also going to expose the key on a different endpoint with seemingly the same privilege
Well, this is
access, like
for being able to share that between the two servers. I believe it's used by like the backup being able to pull down what the original server has or whatever. So
oh
that
right,
it can
okay.
copy the configuration and be running like that. So it kind of needs it, like it needs that information. Like it needs the config, it needs the key. So this will
Ideally,
expose it
like
so it can pull it down.
ideally I wouldn't want like an encryption key being automatically pulled across though. Like I would expect that to be like you set that up beforehand manually or something.
But
But
then, you know, in an emergency when everything fails, because that's the idea here. This is business continuity. That's like, you know, the world is ending. So, well, I mean, not really that bad, but servers are going down. You do want to rely on the fact that somebody remembered to rotate the key.
yeah, I mean I get what you're saying. There's kind of it's a difficult problem. You're kind of caught between two rocks. It's like you either expose the ability to get the key, which to be fair, it is supposed to be authenticated. So it's not like it's just sitting out there on an well, in this case it was, but it's not supposed to be sitting on just an exposed endpoint that anyone can access. Um, but yeah, I mean just allowing an encryption key to be on an endpoint like that is already kind of a dangerous thing. So yeah, I just thought that was kind of funny. But like I said, like usually it's supposed to be authenticated, so that design decision I can kind of get on board with. It's a design choice that they made, but yeah,
Yeah,
just an
like there
interesting
are
attack.
other ways to do it too. Yeah, I mean, this is what I found interesting about this one. Um, well, one is just the amount of things exposed, but it's also a little bit. I'm often kind of hitting on this idea of centralizing security and like, you know, doing all your checks in a central location. And in this case, this is kind of the flip side of that, where had this been ad hoc authentication, everywhere's just kind of running its own, then you're maybe going to have like one or two odd endpoints that have some security issue. Whereas in this case, like everything potentially gets exposed because the problem was in that, you know, one central point. You know, there's that one point of failure. So it is kind of the flip side of it where you do need to be able to trust your centralized security. And in this case, you kind of have a problem with that by them making the you can call that a bit of a breaking change even for the API versions, although I don't think they even version their API so beyond the actual application version, so I'm not sure if that's really something fair to expect of them. But yeah, I mean it's the flip side of centralizing security is when that security fails, everything kind of fails. Although that's where you kind of want to design around fail close instead of fail open.
Yeah, this kind of explores some of the nuance of the centralized security stances that we've maybe talked about in the past, but just haven't really explored this angle. So yeah, it was cool to be able to do that with this topic. But yeah, we do have another topic here, which is a race condition in Reddit via the Google Play Store through their verify purchase endpoint, which takes a transaction ID and token. As you can guess, it seems to be one of those races where it'll add tokens to your account, but there's a race where other requests can get through before it actually, expires that token. So pretty straightforward issue, but we do like seeing races in the web, so we thought we'd give it a quick cover.
Yeah,
But yeah,
it's one of my favorite vulnerability classes, and thank you, Shiro, for the sub. Um, but yeah, it's also kind of fun because this has kind of the monetary impact. I mean, oftentimes you'll see this sort of time of check, time of use vulnerability. Root emails just asking, wait, didn't you cover something similar? We did cover last week. We covered another vulnerability where this was in Reddit, also in purchasing coins. What would happen is when somebody would use the wrong transaction ID, I think it was, or order ID. If they would swap the order ID, they would get the coins from the second order ID, like a newer transaction, but for the price of whatever their first order was. We covered that last week. This time it's you'd basically make like I think is the example here, they made like 10 requests and 9 of them ended up adding coins. So they made one purchase of 500 coins. It got 9 times that amount of coins.
Reddit coin dupe, basically.
Yeah, I mean, this is like, as I've said before, one of the things you need to look for is anytime you've got some event that's only supposed to happen once, you try, Burp Turbo Intruder or NCC Group has a tool for you just want to hit those with as many requests as you can and make sure you don't get things awarded multiple times because this is a relatively common issue. It's just an uncommon scenario where you have something kind of impactful that should only happen once, but it's there. Like many applications are going to have that. It's just not your average situation where you actually need to protect it in that way. So a lot of people just don't really end up thinking about it or considering it. They specifically called this out on the Android endpoint. I would be curious if this also impacted the iOS and they just weren't able to test it or didn't know what endpoint was being used there. Or possibly, the iOS system is just completely different and different code.
It probably is because with iOS, you're talking about Apple. You kind of have to go through their ecosystem, so it's probably more tightly integrated with like the App Store or whatever. They probably have to go through a different API for that, or like a
Yeah,
different route
perhaps.
by necessity. I'm not saying that for sure, but that's my guess, just based on a little bit that I know about iOS dev. But yeah, I mean, interesting bug. The last time we covered a bug like this, where it was like a race condition in the web, I believe, was when we covered a CTF. Was it CTFD? I don't remember what it was, but it
It
was a
wasn't
CTF platform.
CTFD. It was a
I
CTF platform. The author of that one did not disclose what the platform was.
You're right. I think I've made that mistake before, assuming it was CTFD, but yeah, you're right. He didn't disclose it. But anyway, it had kind of a similar issue where you could submit a flag for a challenge, and if you did multiple requests in parallel, you could get awarded points
I mean,
multiple times before it would mark it as solved for your
yeah,
account.
like that is one of my favorite attacks just to toss at any random CTF I go and play. Yes, I know testing without a bounty program, but it's reasonably common when somebody's just writing their first, CTF platform and not really thinking about it. It's one of those issues that once you've encountered it, you know about you're going to remember it. At least that was the case for me. But until you've encountered it, you're just not really thinking about that, or at least not as much. Obviously, if you've got some background in doing like the distributed or parallel computing, sure, it'll be there. You'll have that background, but a lot of web devs aren't necessarily thinking about that.
Well, even outside of web dev, it's just generally difficult to think in like a parallel context. It's
Oh,
it's
for sure. But
it's tough.
like the web, a lot of people write their web code thinking kind of in serial, having everything kind of serialized one after the other, and not really thinking about the fact that you can have multiple requests hitting the same endpoint and actually reaching this code. Like I don't know, I think just the perspective or the mindset in web leads to it a little bit more than when you're actually spinning up new threads and I guess more aware of it.
Yeah, it causes a blind spot for sure. So yeah, I mean I love seeing races in web. So it wasn't as like, once you break it down, it's not a super complex issue, but still, I thought it was cool. So, but we'll move into a more complex issue here, which is in GitLab. So, GitLab, special Markdown engine, which is called Mermaid, which I hadn't really heard of before, has a stored XSS through the use of HTML labels and flowcharts. And it's an attack
So
that involves multiple cascading issues.
just to clarify slightly, Mermaid is specifically for flowcharts in Markdown. Like Mermaid isn't the Markdown configuration. It's specifically like this part. You'll notice in their example, um,
Yeah,
somewhere on this page.
it's part of what they call like the GitLab flavored Markdown or whatever, I
Well,
guess.
no. So you'll notice
Isn't
here
it?
in
I
their
thought it
code
was part of
example.
their.
In the code example, it's in one of the comments. They use the example there. So this is like a triple backtick and then Mermaid saying, use the Mermaid parser on this code. And then it's treating that code because you're in a code block. You're telling it it's Mermaid code. And then it's going to treat it separately because this is specifically for processing those flowcharts.
Right, but Mermaid is used as an extension on what they call GitLab flavored Markdown. Like that's part of um their little ecosystem, I guess, when it comes to Markdown.
I
That's what I was
mean,
trying to say. I was probably botching it a bit, so
it's
my
more like
apologies.
because this is the same place where you would write like, triple backtick and then Python or C.
For syntax highlighting, yeah.
Yeah, although they're doing a little bit more than just syntax highlighting, it's in that same area rather than actually adding to the markdown itself.
Yeah.
At least that's how it seems to be. I did not go and look that up, but yeah, just wanted to add in there like it's not exactly first party, it's just kind of being plugged in. Yeah, go
Yeah,
ahead.
fair to
Sorry.
call out. So yeah, the report talks about flowcharts HTML labels, which I mean it's a powerful feature as the name suggests, and as such it is disabled in GitLab's configuration, and that's through two configuration options. They set HTML labels to false and security level to strict. So reading that, you would think, okay, all should be well. HTML labels aren't being used, but there's also another powerful capability that Mermaid has, which is directives to allow alterations of the configuration. Now, again, because altering the configuration is powerful, they try to prevent the ability to override sensitive configuration options like the security level. You can change the HTML labels variable, but if it's set, it'll check the security level and do sanitization on the input if that security level is set to strict. Um, and it'll do that before rendering the markdown. The problem is their sanitization is broken due to a logic bug where they would allow through the false string for HTML labels, and not force that through sanitization, presumably to allow like regular text through.
Yeah, I mean, I
Um,
don't think that's really a logic bug.
well, it kind of combines
Because
with another issue, which I'm going to talk about here in a sec. But
I mean, it's intended. Like their code is literally if HTML labels is triple equals false, like the Boolean value, or equals false the string. Like it's absolutely intended. Um,
yes, so it's intended there, but there's another place where it's not accounted for, and that's where the problem comes
yeah.
into
Well, in
play.
the secure, they're missing it in the. Sorry, I guess I won't jump ahead of you there.
All good. So yeah, like that false string will be evaluated as true when it decides whether or not to render text or HTML. Um, and you were so sorry. Where were you saying with the secure path? I'll let you go ahead there because I was maybe missing that in my note.
Yeah. So they basically there are a set of attributes that cannot be overloaded by the inline directives. So what we're talking about right now are you've got like the security level, the HTML labels, all of that are your directives. They're called in this Mermaid initialize area. That's where they're set up, and then you have, as you were just saying, both the inline directives, which like you overload them, so you can change some of them, and they have this array called secure, which are the directives that you cannot set using inline directives. So that includes like you can't change the secure attribute, you can't change the security level, start on load, max text size. I'm not sure what the security concern is there with max text size, to be honest. It's probably using it somehow or echoing it or something, but it basically the HTML labels is not included in that secure, so you can overload it, set it to false, or sorry, set it to true, which then means it'll use the HTML that you provide in the label. It'll write it with inner HTML instead of just inner text.
Yeah, so there's kind of this problem where they consider the ability to set the string of false for HTML labels, but like I said earlier, they just don't consider it in some other places, so that allows you
I
to
I mean
bypass the sanitization and get XSS.
I don't really see uh I don't see a huge issue with the fact that it's looking for false versus the false string. I mean, that kind of comes down to parsing or how things end up getting entered and seen in JavaScript. Like, so many things just end up defaulting out to making it a string. So checking specifically for the false string, like, it doesn't seem like an issue to me, and I don't believe the patch made any changes to not checking for the false string. So because the main issue here just seems to be the fact that they don't secure. They let inline directives actually change that HTML label's value, whereas it should be considered just a secure value that can't be changed. Because if that value couldn't be changed by an inline directive, the vulnerability wouldn't have existed.
So what I was referring to there is this sentence down here where they say, however, the code that actually decides whether to render it as HTML or text always uses if config flowchart HTMLs, which would succeed for the string false because it's truthy. So what I'm saying there is they allow the false string through in this area of code that they have the snippet for, but then in another area of code where they're deciding how to actually render the content, they're not checking for that string. They're just doing this straightforward if HTML labels check. And then because of how JavaScript works, like you were kind of alluding to there, this false string would evaluate to true and it would allow it through, even though it shouldn't. So that's what I was talking about there, where there's kind of this desync between the snippet of code they have and this other area where it would decide how to render the input. So yeah, I guess you could kind of put it down to either issue. You could put it down to like that if statement that they mentioned, the if config flowchart HTML labels, that should have been changed to account for the fact that you can pass in strings, or just not allowing the HTML labels to be set from a directive too. So yeah, I guess you could kind of go either way on that. I'm not sure on which way they went on that.
Yeah, I see the point that you're making now. And I had kind of missed that.
Yeah, I was just
In
trying to
that
take a quick look to see if they could, if they elaborated on exactly
I would have
which
a
part they
feeling that
fixed
you
on that.
still might be able to exploit it regardless of that one, but it would make it at least more challenging. Or well, maybe not actually. I do see that would in theory be replacing replacing the angle brackets. Which in that context you might not really have any other way of getting anything of value. Yeah, fair point. I was wrong there.
Yeah, so I was just taking a look. So like they say what is the expected correct behavior, and the author of the report said that Mermaid should not allow HTML injection. Um, just talking about some mitigations they could do, like moving it into a sandboxed iframe and whatnot. Um, but they don't really elaborate on how they fix that. They do, like the researcher does suggest adding the HTML labels into the secure array. So they do at least suggest what you were talking about there, but I don't know if they actually took that into advisement. They're a little bit vague in their responses.
Yeah, I'm
Um,
not sure I'd agree with the author here either on just saying, well, Mermaid shouldn't allow HTML labels. Like, I mean, again,
that is
this,
a choice that they made to support. So
I mean, part of the thing there, though, is this is meant to be like, if I just want to write up a Markdown doc, like write up a flowchart in roughly Markdown, I control that. I want to have HTML because I want to style it my own way. Like, that also makes sense. Like, yes, in this case with user input, it makes less sense to allow it. Um, yeah, I guess like you said, they made that choice. I think it's a fair choice here, like having the ability to disable it. And just arbitrarily decide like, yeah, I want to enable it now is kind of an issue. But I'm not sure the feature necessarily needs to disappear. It could. I think it would be fair to make that move. That's just like, it's a pretty big ask.
I think the suggestion on sandboxing it in like an iframe or something is probably a good idea, though. But yeah, I mean, that's just like kind of like a last suggestion that the researcher makes there.
Yeah,
Um,
it's Etienne and Chav mentions perhaps they could use DOM Purify or something. And yeah, DOM Purify, aren't, and browsers are now actually, at least I think it's going through the RFC process for actually introducing like a first party and browser sanitization mechanism. Uh, so once that lands would be another good solution. Yeah, I mean, not doing this ad hoc XSS protection. That said, their XSS protection wasn't actually broken in this case. Um, so I mean that wouldn't fix it, but I'd still rather see somebody using DOM Purify or something over just doing it ad hoc and doing their own encoding.
Yeah, so you were kind of talking about it there, so we'll get into the impact here. So obviously, this leads to XSS, which in and of itself is mitigated by the fact that they have a content security policy in place. They can't use inline scripts. But because there's the ability to use CI/CD pipelines, you can set up a pipeline artifact with the script that you want to execute. And because Workhorse, which is GitLab's artifact serve application, will use the file type when deciding the content type for serving the artifact, you can kind of bypass the CSP here by using pipeline artifacts to get scripts on the same domain and still abuse the XSS. So overall, this attack earned the researcher $3,000 here. There was some interesting back and forth in the comments as well. One thing that stood out to me was they triaged this issue as a user interaction required, which the researcher was found a little bit weird. Um, and it's actually a really funny thing with this report because technically speaking, like this is a stored XSS. What you're doing here is you are abusing the ability to control a Markdown document to introduce an XSS, and that's going to be in the repository, right? You're so presumably if you just visit a repository that renders that Markdown page, if it's in like a README or something, you're going to get hit with the XSS. So it's not like the user has to click a suspicious looking link or something where you have circumstances present like you would in a reflected XSS. Um, then again, you would still have to get a target to that repository that you can get a malicious Markdown document in. So I can kind of see the user interaction required in that respect. But anyway, GitLab's stance there when they inquired was if it's not a stored XSS in something like our homepage, then they don't consider it a no user interaction required bug. But it is one of those things where the answer just isn't really straightforward, like it is in most XSS cases. So it's something I wanted to call out because
Well,
it
I
was kind
would,
of like this back and forth discussion that was had.
I mean, generally speaking, when you call something when you say like, yes, it requires user interaction, generally that means that you require user interaction in order, like once somebody's on the vulnerable page, it requires user interaction for the XSS to get fired. So in this case, it's stored. You just need to get them to that specific URL. Um, I could understand what they're saying, like, oh, okay, it's not on the homepage. Like that would be a lower priority, but I wouldn't necessarily change the category of it out of it being uh uh not requiring user interaction because it doesn't require actual interaction with the page. It requires that they visit the page, but that is true of any XSS. Like the attack, it exists on some page. I feel like yeah, I don't know. I don't really agree with GitLab here. I mean, as long as they're consistent, I mean, it's fine. They can choose to call it that way if they want to. They're not. I mean, it's all opinions anyhow. Like the impact's lower because of that. I don't entirely agree on that aspect, but I mean, it's fine. I do want to call out one other thing. And this is just more of a little tip. In terms of the CSP, well, not actually the CSP bypass, but with that also, one of the things they couldn't do, they had an inner HTML, right? So just doing .inner HTML, but what they can't do with that is actually inject a script tag using that. You'll be able to inject HTML. So the way they got around that to inject the script frame, more or less a traditional trick for this, but using iframe and then a source doc that contained the script tag in it. Um, just kind of get it loaded somewhere else instead of in the inner HTML, right? They added that trick in there, so I figured I'd call it out.
Yeah, and just jumping back a little bit to the discussion on like the user interaction stuff, Amy in chat kind of put it succinctly with it would still be a one click, but it's not like I would agree with you. It's no user interaction required. All you have to do is visit the page, so it's not a zero click. But yeah, I mean, like you said, it's kind of up to GitLab on how they run their program on that. It wasn't really a major point of contention. Like the researcher wasn't trying to fight back hard on it. They were just like, um, I was just curious what you would classify as a no interaction required. So yeah, it was a little bit weird, but you know, it didn't result in like any bitterness or anything in the report process. Like it was just a curiosity kind of thing. And something I
Yeah, I
thought that I'd
mean,
talk about because it is kind of an interesting discussion. Like I said, it is kind of a weird case. So I could
yeah,
see it kind of going both ways.
as long as I think, as long as GitLab's consistent in how they apply it, I think it's totally fair for them to make that change. Because most people are aware, like on a lot of websites, getting XSS on like any random page is actually somewhat is kind of treated the same. Whereas, GitLab, obviously people understand it's almost all user content. Whereas like XSS on your bank's website or something, that's a little bit less of the user content. So it's more of a trusted thing. So, I mean, there's the fair reason to mark it down over this. As long as they're consistent, fine. And in all fairness, that like when it comes to the bounty hunter, this guy did not like fight back over it or anything. But I know we've covered a couple of cases where people have fought back over some of those changes, and ultimately it does come down to whatever the vendor kind of thinks there. So I
That's
think
exactly why I
his
wanted to call
response
out.
was fair.
That's exactly why I wanted to call out that this was like, just a curiosity thing and not any back and forth like fighting because we have seen that in a few reports recently. So
Yeah, and I mean, fighting it sometimes if the vendor misunderstands something. But in this case, GitHub is being clear, like, we understand why you're thinking that. Here's why, like, here's our reasoning for that. And yeah, I think GitLab handled that very well by making clear we understand what your thought is. Here's our take on it. This is how we treat all our reports.
yeah. So finally, here we have a Discourse SNS webhook RCE. This is from Joran Chen, which covers an RCE in Discourse's AWS notification webhook, which is written in Ruby, which I mentioned because that is important for talking about the issue a little bit. Because basically, this webhook takes a provided subscribe URL and passes that into open, which because of how Ruby works, I think we've talked about some issues before in like Ruby applications where this has been a problem, but because of how open works in Ruby, that can easily be turned into command injection by just providing a pipeline operator. Though that alone wasn't a bug because um, this webhook is supposed to be like authenticated. They do have signing on the payload by AWS, so an attacker isn't supposed to be able to control like pass in a malicious subscribe URL into that. You have to pass a valid certificate file. So ultimately, what the main issue here in this post is a signature bypass. So yeah, they need a signature bypass. So the researcher took a look at the verification code in Ruby and it checks that it performs on .pem files. So with the request, you have to pass a certificate file that passes all of these checks that they do. They verify that the signing cert URL provided is HTTPS. They also do a whitelist check to make sure that the URL is an Amazon AWS URL for SNS, and the path has to end with .pem, which is the common file extension for a key file. There's kind of multiple problems here that combine together to make these checks bypassable. For one thing, it's possible to get a fake certificate reflected in a few different ways. The first way they explored was error handling on the SNS endpoint. So if you passed an invalid action to that endpoint, this error page would get rendered and it would put the invalid action that you specified in the page contents. So through that reflection, you could inject a fake certificate into it. Um, the other problem here that kind of breaks everything is the fact that Ruby's X509 certificate parsing is also doing loose parsing. So if you have a page, like an error page, where you have like the HTML contents and then the contents you control, um, the other contents in the page will just get ignored. It won't actually reject it as invalid as an invalid certificate. It'll just try to parse it and just ignore everything that isn't relevant to the certificate. And further, the host would serve this error page on arbitrary file names. Um, all requests are treated as if they were regular slash requests, which let you get around that extension check I mentioned earlier, where you had to have that .pem file extension. Now, unfortunately, the error page method didn't really work out. It was really cool, but the problem there was when it pulls the certificate, it expects a 200 OK response. And because you're abusing an error page, obviously that's not returning a 200, it's returning a 400. But they did find another way to get a payload reflected in a page without using error pages, and that's using the get endpoint attributes method. That method allows you to pass a parameter called custom user data, which gets reflected into a page as well. So using the same kind of strategy, this one works out because it returns at 200 and it's hosted on its own domain. So it gets past all the certificate checks. You can get a fake certificate hosted on the website, refer to that, and get a payload signed that you otherwise wouldn't be able to. Then you can finally abuse that command injection and the open call to get something like a reverse shell. So kind of a multi-stage attack here that requires you to look at the certificate bypass, because initially, like that initial issue of being able to command inject through open, I mean, that might be an issue, but the problem is it couldn't really be taken advantage of if you didn't have the cert bypass. So the
Yeah,
cert bypass is the main thing there.
um, the author of that code is obviously doing the validation, thinking that that will make or that will secure this area of code. Um, I will mention Ruby kind of like that open has I don't the fact that use it for files, use it for URLs, use it for opening a process and having a pipe to it. Just so many extra features there that feel a little bit excessive.
It's a major sink, that's for sure.
Yeah. That said, this is an awesome bug. I really like it. It's one of those cases where you kind of have to dig into how everything's working, how it's checking, and then just find the false assumption that the developer had. In this case, just assuming, if they provide the certificate on the right URL like that, users couldn't somehow control it in there.
Yeah, that idea of creating a fake certificate through like getting it reflected in a page is just a really cool attack. I mean, anything that deals with crypto and faking certificates is always like immediately interesting to me. So
I mean, they can also be very technical and boring too with some of the crypto attacks. But this one, I
that's
mean, it
true.
doesn't really take place at the crypto level. It involves the crypto, but it's a logic bug. It's just thinking about the issue, understanding the code, understanding the side effects. And I love seeing stuff like that. That's a deeper issue, a much more awesome issue than just my data was reflected somewhere it shouldn't be. Which I mean, in fairness, is a valuable and worthwhile issue. But I love these sorts of things.
So I would kind of classify this as two issues, right? You have the weak checking where they assume that anything on that domain is going to be safe, which, as you pointed out, is broken, and you can get around that with the reflection. The other thing here I would kind of pin on Ruby. and we've talked about this before, like with the X509 certificate parsing, with it being loosely parsed so that you can use like a page in this way to fake a certificate, like anything like this should just be outright rejected. When you try to fix it and try to just say like, oh, okay, maybe there's a valid certificate in there somewhere if we just look hard enough, like it's just kind of asking for problems.
It
So
is.
I would
That
say that's
said,
an issue too. But
as a format, like as a format, it has a very clear delineation between where it starts and where the certificate ends. I mean, it's just, the dashes start certificate and dashes end certificate. Like that, it has a very clear marker, and that allows it to be included in a network package stream. That allows it to be included in a lot of things. So I have a feeling that it's more because of the history on that Ruby's going to parse it this way. I couldn't call out anywhere where certificates are used and it's not just this very clean file. I mean, obviously it comes up during uh like HTTPS and stuff. Obviously, it's sending certificates during that. I'm not sure what that actual parsing ends up looking like. Because I feel like that would be a little bit different than where you'd be using Ruby like this. But on a whole, like I get it because this file format is kind of just made in such a way that it fits in anywhere. It
it
feels a
just feels
little
like one
bit
of
like there's
those
just tradition behind it.
it just feels like one of those things where it should be a secure by default thing where like, okay, if you need the ability to parse a certificate out of like data that can contain more than the certificate, then you can specify that in the options when you call it. But by default it should just be looking for like just certificate contents. But I don't know, that's my opinion. There might be some specific reason or some use case they have in mind why they have it this way. um
Yeah, I
but
totally
yeah, like
agree with you that like it is that would be the more sane and like a better default. I completely agree with you there. Like I said, I just think there's probably some tradition or some historic reason for why the parsing is generally done this way. And I don't think Ruby's alone in doing the parsing like that.
Yeah. I mean, the reason I wanted to call it out here is that if the certificate parsing was a bit more sane and it just outright rejected, um, like this kind of case where you could just pass in page contents, this attack would not be a thing. Like, they wouldn't even have to consider this idea that somebody could reflect a certificate on the page because almost certainly they're not going to be able to control the entire page contents, just a part of the page. So, yeah, I mean, if the parsing was a bit more strict there, this attack doesn't happen. But yeah, I mean, it's again, maybe a tricky problem. There might be some use cases where you would want to pull a certificate out of some larger set of data, but yeah, I mean, in this case, it just seems like you know, designed to be abused in this fashion. So, but yeah, overall, like we were saying earlier, like very, very cool blog post, kind of involves understanding multiple aspects and how the checks work, and yeah, just a cool attack. But yeah, so that pretty much sums up all the topics that we have for this week's episode. Thank you to everyone who tuned in. You can catch the pod on Twitch or on YouTube at 6 p.m. Eastern tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below in the description, and I'll also put our Discord in the Twitch chat. We'll be back tomorrow for the binary episode, which is at 7 p.m. Eastern, 4 p.m. Pacific, which is also where we'll cover the spot the vuln solution that was shown in the pre-stream. That's also in our Discord for those of you who might have missed the pre-stream. And yeah, other than that, we'll see you tomorrow.